A very warm welcome to one and all. So, today we have our lab session. So, in our lab session, we are going to, spend some time on the tool which are going to use in the compiler lab for execution process, which are lex and also known as flex, or one more tool we will use in later session of the lab, which is known as bison. Now first, before going to lex tool, we need to understand why we need the lex tool and for what we need lex tool, right? So now the first thing that we need to do is a lexical analyzer generator. This is the expanded form of a lex, or we can say the use tool for lex. So lex is a program generator designed for lexical processing of character input streams. So as you know, the first phase of compiler, which is a lexical analyzer, which aim is to break the entire piece of code into the stream of tokens, right? So for that purpose, lexical analyzer generator is used. Now, lex tool is a table of regular expressions and corresponding program fragments. So in our second lecture of compiler, as you know, I discussed the regular expressions. So probably you are familiar with regular expression. So regular expression is one more important entity from the point of view of using lex or lexical analyzer generator. Now this table of regular expression is translated to a program which reads an input stream, copying it into an output stream and partition the input into strings which match for the given expression or for the given patterns basically. So these are the points about lexical analyzer. We'll continue regular lexical analyzer generator. Now the program fragment written by the users are executed in order to which the corresponding regular expression occur into the input string. It means when we provide a regular expression, it has a certain pattern, like suppose if I talk about an identifier, so identifiers always start with a alphabet, and it might be end from an alphabet as well as from a number. So it is a fixed pattern. It cannot be start with a number. So this the first statement is related to this example. Now lex can generate analyzers in either C or RAT4 or a language which can be translated automatically to portable Fortran. So this statement is a bit deeper from the point of view of compiler, because in later lectures of compiler design we will see the concept of bootstrapping in cross compiler. Now in bootstrapping in cross compiler we will analyze how the source language is converted to the target using the host. So the C language is basically is automatically translated to a portable Fortran. So Lex is another Lex is a tool that used to generate or analyze the Lex or utilize the Lex tool. Now next point is Lex is a program designed to generate scanners, which also known as tokenizers, which recognize lexical patterns. As I discussed, it is basically used to recognize the lexical uh, patterns, or that break down these patterns into lexemean and then further tokens. So basically it is a tokenizer, rather we will say another acronym is tokenizer, right? Now, Another acronym of LEX is lexical analyzer generator. This is correct. I discussed earlier. Now these are some points. Now LEX can be used with a parser generator to perform lexical analysis. So to complete the process of lexical analysis, Lex is use a parser generator also with it. For example, like Lex and Yak. Lex is stand for lexical analyzer generator and Yak stand for uh, yet another compiler. These are the open source programs basically that generates the code for the parser in C programming languages. The next point is Lex can perform a very simple transformations by itself to main purpose to facilitate the lexical analyzer. So lexical analysis is the main phase of compiler in the first phase. So to perform this, the lexical analysis entirely, and it in itself, or we can say the Lex is the best tool that transform the given piece of code into the stream of tokens basically. The processing of characters sequence as a source code to produce symbol sequence called tokens and for use as an input to programs such as parsers. Basically, what it means, what does it statement means is when entire piece of code goes to lexical analyzer, then uh, you know it breaks into the sequences basically, and these sequences called as lexemes, and the lexemes finally goes to you know some kind of pattern over there uh, to the lex, and finally they are validated in form of tokens with the help of parser. Now what are the process in lexical analysis is the first process is scanning, then pre-processing, then correlating error message, and then lexical analysis. Scanning means the entire code will be scanned character by character. Then pre-processing means expand the macro definitions where we define like this: define max. Let's suppose max is equal to 3. So wherever max is assigned to the each location of the program, it will automatically expanded by the its value, whatever its value. Now next is correlating error message with compiler, from compiler with source program. Its another goal is to indicate the error basically at the particular line and the particular code segment in the entire program. Next, uh, the terms of lexical analyzer which we will use. First one is a token. A token is it a type of words. It might be a keyword, it might be operator, it might be a identifier, a constant, a literal, or anything like punctuation symbol, like say comma, semicolons, and so on. And next word is lexeme is basically a sequence of character, nothing else. Now once a lexeme is built, now this lexeme goes to a pattern and then finally it is converted into token. Now this is the pattern, a rule. Basically a pattern is what? A rule that describes a set of lexemes. Right now, less than, you know um, uh, sorry, greater than equal to, less than equals to, not equals to. These are the relations basically that we will see in our daily life. So these are basically the patterns. Next is lexical errors. So there are certain types of lexical errors. deleting an extraneous character, inserting a missing character, replacing an incorrect character, or pre-scanning. So these are some errors that we will see uh, into when we use the Lex tool. Now this is the whole compilation process basically. This is the first phase of compiler: lexical analysis, then syntax analysis, then code generation. This is very short description basically. Now this is the string. This is the source code. Let's suppose a is equals to b plus c into d. Now when this code goes to lexical analyzer, it just converted into the tokens. Now these are the tokens. This is identifier. So identifier number 1, identifier number 2, identifier number 3, and identifier number 4. Now these token goes to syntax analyzer and further converted into a syntax tree, uh, and so on and so forth. We will not discuss about the code generator and syntax tree and generated intermediate code because it is not related to Lex tool. Now, what is a Lex basically? We have seen about the Lex in our earlier slides. Now we'll see what is Lex. The main task of a lexical analyzer, which is also known as scanner, is to break up an input stream into more usable elements. That elements is known as tokens, like a is equals to b plus c multiplication d. So this is an identifier, assign, then identifier, then plus, then identifier, then mult, then identifier, then semicolon. Now what are these? Now these are basically the tokens, and Lex is an utility to help you rapidly generate your scanners. Now next point, lexical analyzer tokenize input string. The tokens are the terminal of a language. So first we need to understand what are the terminals. Basically the terminals are known as, in automated theory we have seen the terminals. So the terminals are always known as the input that we will provide. Now what can be the terminals? They can be words, they can be punctuations, they can be identifier, they can be operator, they can be keywords. In terms of programming language, they are identifier, operator, and keywords. In English language, they can be word, they can be punctuations, right? Now next very important term is regular expression. So the regular expression is basically plays a role into a lexical analyzer like a pattern, right? Now pattern is an area where every uh, lexemes get validated, and after validation it just converted into a token basically, right? Some examples of type of lex is flex. This is again called as fast lexical analyzer, yak, regel, and ply, python lex, yak. So there are several like tool like lex. Now this is the entire process. First we have source code. Then this source code goes to Lex, and that it will convert into the YY Lex, right? YY Lex program will recognize the expressions in a stream and perform the specified actions. So this is very responsible program. Now this is the main program to which we will provide an input, and finally stream of tokens or the output we get. This is the overview of a lex. Now what is YY lex? Basically we will go a bit deeper inside the YY lex. It implies the main entry point of a lex. This is the main entry point. It again reads the streams that generate the tokens and returns 0 at the end of input stream. So why it is doing so? It is doing when uh, a lexeme goes to a pattern, then it get converted or validated into a token, and message passing system is maintained over there. Now every time when a token is returned, then it intimate to the previous section that send next lexeme to me for conversion of tokens. So this is a handshake lemma basically. So after a generated tokens, so every time it returns 0 at the end of input stream. Now it is called to invoke the lexer or scanner. Each time YYLex is called, each and every time it is called, when lexemes get converted into token, the scanner continues processing the input from where at last left off. So there are several functions like YY out, YY in, or YY wrap. When we go into the lab session, we will see the each functions like YY out, YY in, and YY wrap also. Now, this is the lexical analyzer's entire process. We have a source program, like the source program will be in form of file which is extension of with I. Let's suppose this is lex.I. Now this lex.l, sorry, lex.l is goes to lexical compiler, then it will convert from here lex.yyc file. Now this lex.yyc file will be goes to C compiler, then it will convert into a dot out. Basically this is the YYLex that we have discussed in earlier slide, YYLex. Now this is the file that we required. Now to this file we will provide an input stream that will convert into the sequence of token. This is the main definition of this is a main a course of a lexical analyzer, or main role of the lexical analyzer generator. Now, if I talk about the lex file, then what kind of structure of a lex file may be there? We have three sections over here. First is the definition section, where we define certain number of header files and all. Then we have the rule section. Rule section means, what does mean by rule section? Rule section are the I frequently use a term that is known as pattern. So pattern is defined inside the rule section, and then finally we use the C code section for working the entire lex file in form of functions. Like if I talk about the definition section, like if we talk about the definition section, so the definition section is like this, where we define the header file. Now this tells Flex to read only the input file. We maybe use another header file over here like conio and all. Now this is the rule section. The rule section defines such kind of instructions like 0 to 9 plus 0 to 9 plus. What does it mean? It means it is a regular expression basically. Now what this regular expression is saying, it says its at least length should be 1, because plus operator is over there, and there should be the numbers, not an alphabet, right? Now this is the means matches the string of one or more digit. It also signifies that it can be match one or more digit, but at least there should be one digit, right? Now if it happens, so it will print, right, an integer value. Otherwise ignore all the character that we have inside a program. So this, like this, we have the rule section. Then finally the third section is the code section. Now in the code section we will provide uh, the entire code. In entire code, the code will be looking like int main void will call the main function. In main function we'll call the yylex, As we know, yylex is the responsible function that will convert a dot out function to which we will give input and we will get output. Right. And now if I, let's suppose, if I give an input to this program, then every time it will recognize an integer. What integer you have seen over here? 1 2 3 and 2 and 6. So because this is just giving you information about an integer value. So an integer value is saying uh, for a number. Why? Because in rule section you have defined only the integer value. If you define an identifier, then it might be possible, then ABC will be treated as an identifier, Z will be treated as an identifier, and entire this pattern will be treated as an identifier, right? Now this is the fast scanner generator. Now, these are some points that I have discussed already. This is basically the working of using the flex tool, right? So this is very short working. Now, this is the point. How can we install lex? Firstly, uh, in a machine. Basically I skipped the previous two slides. Why? Because these two slides contains a very short description about how we utilize the lex tool. So we will go step by step in our lab today. So first of all, the prerequisite is basically the Ubuntu. You should have Ubuntu in your machine. If you don't have Ubuntu in your machine, then you may install a virtual box, virtual machine, virtual Ubuntu machine in your machine, so that you can utilize, you can do the lab sessions for the lex tool, right? So first of all, this is the snapshot. In this snapshot, what we are going to see is we have a terminal. On terminal we will write over here sudo apt dot get update. So first of all we will update this, and it will require the password. When we insert a password to this terminal, then it will automatically update the entire system. Then we will write this command sudo apt dot get install flags. Then it will again require, it will again need a password, and finally it will install automatically. You need no not to do nothing, do anything, right? Now finally we just install sudo apt get install bison. It is the tool that is used in our lab session 2. Now again it will require password, and finally it will install bison as well. So in today's session we will you know uh, keep in mind that the first thing that we understood today is the working of the lex tool, and uh, what is basically a lex tool and what are the entities that makes an entire and itself a tool, a tool which is called as lex. Like we should have a pattern, we should have lexeme, we should have some kind of rule through which the entire lexical analysis processes are performed to tokenize, for tokenize the input source code. Now that the very important thing that we need to keep in mind is, firstly, you have to study about the flax and bison. Today, I'm instructing you. You have to study about the flax and bison in very very detail. Then another prerequisite of the lab is, for you guys. You should have the uh, Ubuntu in your machine, because in Ubuntu system, Lex tool is utilized very efficient manner. Otherwise, there might be possible that Lex tool is used in Windows, but I'm not, I'll not suggest you to do so, because it is very, a tedious process. It is not an easy process. So try to install the Ubuntu or a virtual machine in your computer, so that you can able to install the Lex and Bison in your machine. So in uh, and the last thing of about today's lab session is, you need to focus on regular expression. So learn about the regular expression, explore the regular expression जितना हो सके, राइट. सो आज के लिए इतना ही रखेंगे हम लोग. इन नेक्स्ट वीडियो और इन नेक्स्ट लैब सेशन वी विल try to explore the course of the lab session. बिकॉज जब तक हम लोग थ्योरी क्लासेस में ये नहीं पढ़ेंगे कि हाउ द रेगुलर एक्सप्रेशंस आर बिल्ट एंड हाउ लेक्सिमी इज गो टू द रेगुलर एक्सप्रेशन, और कैसे वो एक टोकन में कन्वर्ट होता है. कहने का मतलब ये है, द मीन इज कि जब एंटायर प्रोसेस, जब तक हम लोग ये लेक्सिकल एनालिसिस का नहीं देखेंगे, तब तक हमें प्रोग्राम नहीं करना चाहिए. तो एटलीस्ट आज की लैब में जो प्री रिक्विजिट है वो मैं आपको बता चुका हूँ कि आप एक तो रेगुलर एक्सप्रेशंस के बारे में आप एक्सप्लोर कीजिए. देन सेकेंडली, यू शुड हैव उबंटू ऑपरेटिंग सिस्टम इन योर मशीन एंड इंस्टॉल द लेक्स एंड बाइसन एज आई डायरेक्टेड. और थर्ड जो चीज़ें हैं, तीसरी चीज़ ये है कि हम लोग अ, हम लोगों को बुक मिली है, या मिल जाएगी आप लोगों को लाइब्रेरी से, कंपाइलर डिज़ाइन का होल मैन. थोड़ा उसको उसमें जाइए और एंड ट्राई टू एक्सप्लोर द लेक्सिकल एनालिसिस सेक्शन इन दैट पर्टिकुलर बुक. सो नेक्स्ट वीडियो लेक्चर, जब भी आपका नेक्स्ट जो लैब सेशन होगा, उस वीडियो लेक्चर में मैं आपको बताऊंगा कि कैसे हम लेक्स टूल को यूटिलाइज करते हैं. कैसे एक छोटा सा प्रोग्राम बनाऊंगा मैं आपको, उस छोटे से प्रोग्राम में आपको दिखाऊंगा कि कैसे कैसे रूल सेक्शन, कैसे कैसे डिक्लेरेशन सेक्शन, कैसे कैसे सी कोड सेक्शन के थ्रू कैसे हमारा एक प्रैक्टिकल परफॉर्म होता है. तो आज के लिए हम इतना ही रखेंगे. सो दैट्स इट फॉर टुडे. थैंक्स. थैंक्स.